Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's Learn How to Sudoku. And of course with a very easy puzzle, and the puzzle is called 13 Rooms by Wook. And here are the rules. Standard Sudoku rules apply, which means place the digits 1 through 9 once each in every row, column, and box. Numbered rooms. Clues outside the grid indicate the digit, which has to be placed, in the nth cell in the corresponding direction, where n is the digit placed in the first cell in that direction. So, for example, if this were a 2 in this cell specifically, what this is saying is that a 9 has to be in the second cell going in this direction. So there, because the 9 is outside, so that's the numbered rooms clue. So that's the digit which has to be placed in the nth cell. And this is an nth cell. N is the first digit here. So therefore, this would have to be 9. Similarly, if this were, say, a 6, that would mean that the 9 has to be placed in the 6th cell. So this would have to be a 9 then, if that's the case. And that's how numbered rooms work. Between lines. Digits placed in between lines must be strictly between the digits placed in the circle at the ends of those lines. So the between lines are here, here, and here. So again, the circle obviously doesn't count as part of the line for the between lines. But the line for all the between lines, that's saying that every digit on the between line must be strictly between the digits that are placed on the outside. And an example of this, so say, simplest example, say this was a 1 and a 9. Well, all the digits would have to be in between those. If you had a 2 and a 9, that means all the digits on the line in between must be between the two digits. So, for example, a 1 could not be on this line, and that's how between line works. Digits along the marked diagonal, which is this diagonal, cannot repeat or do not repeat. So, again, you don't have repeats on this diagonal, and this is called the negative diagonal because in mathematic theory, you have basically a positive diagonal where you have a 1-to-1 ratio and a negative diagonal where you have a 1-to-1 ratio. So this is normally called the negative diagonal in variant Sudoku communities. Digits in cells separated by a black dot are in a 2-to-1 ratio. Not all dots are necessarily given. So these are normally called crop key dots. And in this, we have a 2-to-1 ratio between the dots along it. So therefore, if you have a 2 here, this would have to be a 1 or a 4 to maintain the 1-to-2 ratio between them. And that's how black crop key dot works. And those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay. So simple thing, if you for black crop key dots, if you ever have 3 or more in a row, it must contain 2 and 4. So it must be, and if you have 4 in a row, obviously it has to be 1, 2, 4, and 8, right? Because those all are the only ones that maintain a 1-to-2 ratio with other digits. So it's either, for example, this is 1, 2, 4, or 8 that way, or it's 1, 2, 4, or 8 that way. Right. So therefore, 6 has to be either 1 or it has to be 8 in the 8th position. Well, it can't be in the first position. And also, in numbered rooms clues, unless the digit is 1, the n can never be a 1, right? Because 1, if you try to place it in the first cell, It is the first cell, right? So you can never have a 1 in the end cell here. Therefore, this has to be 8, this is 4, this is 2, and this is 1. Which means 1 along this diagonal, since we know there are no repeats, it's basically just the digits 1 through 9. Therefore, you have to have a 1 along this diagonal, and the 2 can only be between 1 and some other number. So 1 has to be one of the endpoints on this line, or on this diagonal. Since we know 6 has to be in the 8th position, this has to be 6, obviously. Now, 6 can never be, so 2 can never be here. So 6 can never be in the 2nd position. And we already told you that unless the outer digit clue for a number rooms clue is 1, you can never have 1 in this position. Therefore, you need a 6 somewhere. It cannot be in the 2nd position in either one. It can't be in the 1st position in either one. Where can it be? It has to be in the 3rd position. Therefore, there has to be a 3 in one of these two cells to accommodate, right? We also know, we know the 8 has to be in the 3rd spot for this row, so therefore 3 has to be here, which means this can't be 3. We have 3 in the corner, we celebrate, but this also means that 6 has to be in the 3rd position here. Therefore, this must be a 6. So this can't be 6. Again, 1 cannot be in any of these two spots because that would say that 6 has to be in the 1st position, which obviously 1 would counteract, and then, or 8 would be in the 1st position, which obviously the 1 would counteract. So 1 cannot be either of these two spaces. 1 can never be on a between line because what can 1 be in between for a digit? The only 1 would have to be 0, right? But the 0 is not in normal Sudoku. Therefore, 1 can't be here either. Therefore, we know 1 has to be here for box 1. And this is box 1 because we usually count box, and this is just what do we call it? It's a norm. This is what normally we have as a norm. We have normally that what is it? That this is count as box 1, this is box 2, this is box 3, this is box 4, 5, 6, because it's in reading order for the Western world. Anyways, so in box 1, we have what? 5, 7, and 9 remaining. Now, here we know that the 8 has to be in the 6th spot, so this has to be 8. Now, 8 can no longer be in the first 3 spots in row 2 or the next 3 spots in row 2. So this has to be 7 or 9. So this is 7 or 9 because it has to be one of these two. So either this is 8 or this is 8. Now, here we know, okay, so 6 has to be the 3rd spot and 6 has to be the 8th spot. So 6 in row 2, in column 2, cannot contain a 6 in 1, 2, or 3 positions, or 7, 8, or 9. So it has to be 4, 5, or 6, but we already had a 4 and a 6 in box 1. Therefore, this has to be a 5. So this is 5, and therefore that makes this the 6. And that's a very common how do you say it? It's a deduction, essentially, that you can have for any numbered rooms clue. If you have 3 or even 2 of the same digit as the number rooms clue digit, you know that one of them has to be from 1 through 3, one of them has to be from 4 through 6, and one of them has to be 7 through 9 if you have 3. If you have 2, you just know they have to be different sets. So one could be 1 through 3, one could be 4 through 6, or one could be from 7 through 9, but you cannot have 2 of the same set. So in this one, we know you cannot have a 3 here because this is 3. You can't have a 1 here because this is 1. So where is the 4 possibly? the 4 can only be in the second row, right? Because you cannot have 1 or 3 here, but you have to have 1 from 1 through 3 in one of these cells to make this numbered rooms clue work. So therefore, it has to have a 2, which means the 4 has to be in the second spot, which means the 4 is now in column 1, has to be in the third spot because it's either here or here. And this can't be 2, obviously, because there's 6 there. So 4 has to be one of these two, which makes 2 have to be one of these two. Also, we know this is a 1 to 2 ratio between these two digits. Well, 1 is ruled out, so you can't have 1, 2. You can't have 6 in there because the 6 is here, so this can't be 3, 6. So it has to have 4 with either 2 or 8. Well, if the 4 can only be in one of these two spots, so therefore this has to be the 4. And therefore that makes this be a 2 because that's saying that the 4 is in the second cell in the row. So therefore that's the 2. We now know that these have to be one from 5. It cannot be 4 or 6, right? Because we have now the 4 or 6 in the box. So this has to have one digit from 4, 5, and 6 to make sure that the 4s aren't in the same box. So one's from 4, 5, 6, and one's from 7, 8, 9. This could be 7, 8, 9, and 4, 5, or 6. So 5 has to be also one of these two digits. And then the last one could be 7, 8, or 9. So this is 5, 7, 8, or 9. Okay, so we know 5 is here, which means 5 has to be one of these two cells. Because we know 5 has to be here, 5 has to be here. That eliminates these 6 cells, so therefore one of these is 5. This is either 7 or 9, but the problem is if it's 9, 9 can never be in a between cell, right? So 9 has to be either an endpoint or outside the between cells. So therefore this can never be 9, this has to be 7, right? Because 9 can never be in between another digit and anything below it, right? Because 9 is the highest digit. So therefore this must be 7, which forces this to be 9. This can no longer be 9. We have a 7 here, which is in between lines, so therefore this must be 8 or 9. In addition, we know there has to be a 9 somewhere on this, because 9 can never be in the between line, right? So 9 is either here or 9 is here. Similarly, on this diagonal, since we know the diagonal is 1 through 9, because there are no repeats, the 9 can only be at the endpoint or outside the, and this can't be 1 anymore because we have a 1 here. So the 9 can only be on the endpoint or outside the line, between lines, right? So it has to be one of these two. Now we have a 9 that we know has to be in rows 8 or 9 in column 2, and we have a 9 in box 9 that has to be on row 8 or 9. So we have a 9 here, we also have a 9 here, so we have 2 9s in row 8 or 9 already accounted for. So the rest of the rows in the rest of the cells in rows 8 and 9 cannot contain a 9, therefore. Therefore, these cannot be 9 because they're ruled out by this 9 pair, this 9 possibility, and this 9 possibility. So the 9 in box 8 has to be one of these 3 cells. Now, if this is an 8, it can only be next to a 4 in a 1 to 2 ratio. Well, the 4 is already here, so this can never be 8 then. So that can't be 8, which forces this to be an 8. This can no longer be 2, 4, or 1, 2. So 2 is ruled out. Therefore, this has to be a 3, 6 pair. So this is 3 and 6, which means the rest of the row cannot contain a 3 or 6. It can't be 1, 4, 8, or 9. So it must be 2, 5, or 7. So this is 2, 5, or 7, this is 2, 5, or 7, and this is 2, 5, or 7. However, if the 2 were here, what would this numbered room digit have to be? The 2 would be in the second spot, but we already have a 2 in the column, so you can't put a 2 in the first cell. So this can never be 2. This is 3 or 6. It has to be with another 3 or 6. So therefore, right, because whatever it is can only be in a 1 to 2 ratio. If it's 3, it can only be in a 1 to 2 ratio with 6. If it's 6, it can only be in a 1 to 2 ratio with 3. Therefore, this is 3 or 6. So therefore, this can't be 6 anymore, which forces this to be 3. And that forces this to be 6 to maintain a 1 to 2 ratio, which forces this to be 3. Okay, this can't be 1, 2, or 4, so it could be 8, or it could be 3 or 6 to maintain 3 or 6 to maintain a 1 to 2 ratio. However, this cannot be, this could be 4, so 8 and 4 still works. If this is 3, this would have to be 6, but that can't be 6 because this 6 sees it, so this can't be 3. If this is 6, this would have to be 3, but again, on this negative diagonal, we cannot have repeat. So the 3 eliminates that from being a 3. Therefore, that forces this to be 4 and this to be not 9, but 8. So we therefore know the 8 has to be one of these 3 cells in column 4. Let's see, what else do we have? 9, of course, cannot be in the first position, and 9 cannot be in the 9th position. So it could be in the second, can't be third because of the 3 here. Could be fourth. Okay, can't be second because the 3 is already in the 9th position, so this can't be 2. It could be fourth because 9 could be there. It cannot be fifth because of that. It could be sixth because it could be there. It could be 7, but it cannot be 9th. So this is 4, 6, or 7. This can no longer, 4 has to be in the 5th position here. So this has to be 5, which means this is 7 or 8. So 5 has to be one of these two. Sorry, 4 has to be one of those two because of the 7 or 8 in the numbered room clue. This again can be 4 or 1, and it's with 7 or 8. This cannot be 2. What can these be? This can't be 9, obviously, so 9 has to be one of these two clues. So, and they could be 3, 7, or 8. So this could be 9 also. This can't be 7 because of this 7. This could be 2, 3, or 8. Right? Cannot be 9. And this is 2, 3, 8, or 9. We're not sure which. Okay. So let's see. What else do we have? This is a 6. Or it has a 6 on the outside. We know 2 is on the inside, so this cannot be 2 here. We have 1, 2, 3, 4, 5, 6, 7 digits that are smaller than this one because these are all in between, so they must be smaller than this since 1 is the bottom. Therefore, there's 1, 2, 3, 4, 5 digits that are smaller. And then 6, 7 digits that are smaller. So therefore, this must be 8 or 9. Therefore, we have an 8, 9, 8, 9 pair in row 8. The rest of the row cannot contain 8 or 9. So this can't be 8, and this can't be 8. This is in a 1 to 2 ratio. This, however, eliminates 1, 2, and 4. The 3 and the 6 are eliminated this way. What can this cell be? It can only be an 8. Therefore, this is 8. Therefore, that forces this to be 9. This is a 1 to 2 ratio with 8, so this must be 4. This can no longer be 9. Therefore, this is an 8, and therefore, this is a 9. So this can no longer be 8. That can't be 8, so that makes that a 3, which makes this a 2. This can no longer be 3, and it can't be 8 because of this 8. Therefore, this is a 7, 9 pair in box 4, which means the rest of the box cannot contain 7 or 9, which forces this to be 8. So this can't be 8, this can't be 8, this can't be 4 because of this 4. This has to be 3 or 5 then. And this is 3 or 5. Okay, this can no longer be 8. Where is the 8 in column 4? It can only be in that cell, so therefore this is 8. 2 can't be the first cell. 2 can't be the third cell because of this 2. So 2 can't be 1 in the first cell. It can't be 2. Sorry, can't be 2, obviously, because we already eliminated that earlier. Can't be third in the third cell. Can't be in the fourth cell. It could be in the fifth cell, but this 5 prevents it. It could be in the sixth cell, so that's possible. So this could be 6. It could be in the seventh cell. It cannot be in the seventh cell because of this 2. It can't be 8. This can't be 8 because of these 8s. And it can't be 9 because it's already filled. Therefore, this must be 6, and this must be 2. So this cannot be 6 then. We know this is between, okay, so there are 5 digits in between these 2 points. Therefore, 9 is the highest point you can have. Therefore, this must be the lowest point. And therefore, this has 6 digits already that are greater than it. Well, 5 can never have 6 digits that are greater than it, and 7 can't have 6 digits that are greater than it. Therefore, this must be a 2. So this is 2, which means this can't be 2, which means we have a 5, 7, 5, 7 pair in box 2. That eliminates 5 and 7 from the rest of the cells in that box. So therefore, this has to be a 4. So this is 4, which tells us that the 9 has to be in the 4th cell. So therefore, this is 9. This can no longer be 9 then. Now we have a 1, 2, and a 3. No, 1, 2, and a 9 in the rest of box 2. So this could be 1 and 9. This could be 1 or 9, but it can't be 2. Where's a 2 in box 2? It has to be here. So this is 2. And we have a 1, 9, 1, 9 pair now in row 3. That eliminates 1 and 9 from the rest of the row. We also can't have 2, 3, 6, 7, or 8. So the rest of the row must be 4 or 5. Now, 5 can never be in the third slot because we have a 3 here. So obviously 5 can't be the third one seen. So therefore this must be 4 and this must be 5. So 5 can't be in the first slot. Actually, neither of these can be in the first slot because obviously from what we told you before, number rooms cannot have, unless there's a clue outside, which is 1, number rooms, the first digit in the number next to a number rooms clue can never contain a 1. So therefore, this must be the 1 in box 3. And we have 7 and 9 left over. This can't be 9 because of this 9, therefore this must be a 7, which forces this to be 9, which means the 5 is in the 9th cell, so therefore this is a 5. And the 6 is in the 7th cell, so this has to be 6. This can no longer be 5, so this is now a 3, which makes that a 5. All of these clues are between 2 and 9. What does that leave outside? It has to be 1, because 1 can never be between 2 and 9. So therefore, this is a 1. And the rest must be 4. This can't be 4, so therefore this has to be the 4, which matches with the number of rooms clue, because that's an 8. And the rest are, what, 3 and 8. This can't be 8, so this must be 3, which makes that an 8. These must be in between, so it has to be a 6, 7 pair. This can't be 6, so therefore this is 7, which makes that 6. And now we're probably just doing Sudoku. The 2 is in the 6th spot. This can't be 7, so this is 5. This is a 7 then. What else do we have? We have a 5, 6 pair here. Therefore, this can't be 6, so that makes that 5, which makes that 6 by Sudoku. This has to be 2, 3, and 7. This can't be 3, so this is 2 or 7. This can't be 2, so this is 3 or 7, and this still could be 2, 3, or 7. Okay. Here we have a 1, 2, and a 5. No, not 1, 2. 1, 3, and 5 missing. This can't be 5, so this is 1 or 3. This can't be 5 because of this 5, so this is 1 or 3. This can't be 3 because of this 3, which forces this to be 1, that to be 3, and this to be 5. what's left here? This is 2, 5, and 7. So this can't be 5, so this is 2 or 7. Oops. This can't be 5, so this is 2 or 7, but it can't be 2 either. Therefore, that forces this to be 7, which makes that 2, and therefore this must be 5. This can't be 2 anymore, therefore this is 7, which forces that to be 3. And this can't be 3 or 7, so it's 2. And yeah, as I said, this is normal Sudoku. This can no longer be 7. This can no longer be 7, whereas the 7, and this can't be 1, actually, because of this 1. So this must be 4. That makes that a 1, which makes that a 7. This is a 6-9 pair now. This can't be 6, so it must be 9, which makes that a 6. That can't be 9 anymore, so that's a 1. This is a 9. This has to be 1 or 1. Wait. Huh? I think I messed something up. Because this has to be 1 or 3, but this is a 1. Huh. Okay, let's go backwards then. Are all the ones separate? Yes. Are all the twos separate? Yes. What about all the threes? Yes. Are all the fours separated? Yep. So 6 is in the 3rd position, 6 is in the 5th position, and 6 is in the 8th position. That's fine. 8 is in the 3rd position, 8 is in the 9th position, 8 is in the 6th position. 6 is in the 7th position, 5 is in the 9th position, 9 is in the 4th position, 2 is in the 6th position. This has to be 1, 4, or 9. This can't be 4 or 9, therefore this is 1, which makes that 9, which makes that 1, so this has to be 4. This then is 9. This has to be 3 and 6. Obviously this can't be 6, so this must be 3, which makes that 6. This can't be 3. We're going a different way because I messed something up in the previous way. So there's a 2-7 pair in box 9. So the rest of the cells in box 9 cannot contain a 2 or 7, so this can't be 7, therefore this is 3. This can't be 4. This has to be 1 or 7, so it cannot be 1, therefore this is 7, which forces this to be 1, which makes that a 7, which makes that a 2, which makes that a 7. Therefore, this has to be 4, because it can't be 1 or 7. This has to be 2, and this is 5. This has to be 1 or 7, and it cannot be 1, so therefore that's a 7, which makes that a 1. The 2 can't be here, so this must be 2, which makes that a 9. Therefore, that can't be 9. That must be 7, and that must be 9. I'm not sure where I messed up in this previous one. Sometimes it helps to basically go back and basically go to a state where you know you were good and basically rewind it that way. Obviously, I made a mistake somewhere earlier. Maybe you can tell me in the comments where you saw it. Anyways, I hope that makes sense, and I hope you enjoyed this Learn How to Sudoku. And I'll see you next time on Learn How to Sudoku. Take care.